Hi everyone, today we are going to talk about how 5G technology can be a stepping stone into building smart ports or harbour cities around the world. This may seem wild, but 5G was first used in experimental trials in 2014 and it also started rolling out for public use in certain cities in late 2018. So the implementation of 5G in ports is not really something imaginable but achievable. One of the reasons why 5G is introduced to ports is because there are several problems faced by current ports, and one of the problems that current ports face is low efficiency. So, in order to combat low efficiency, 5G has the capability to travel at a higher speed in higher frequencies due to its nature, known as millimeter waves, having the frequency between 30 GHz and 300 GHz, which is 10 times faster than the 4G we are currently using. This is because of the higher frequency, 5G also has a larger bandwidth than 4G. Bigger bandwidth means more data can be sent over a connection in a given amount of time, which is very crucial for the amount of data that needs to be received, sent, and processed in the port's communication, hence improving the productivity and efficiency of the port. Besides that, 5G also provides an extremely low latency. This means the delay between the sending and receiving of information is low, where we can observe the latency of current 4G of 200 milliseconds being drastically reduced to just an impressive delay of 1 millisecond with 5G. Isn't that extremely good in helping the fast-moving pace of data in ports around the world? Moving on, since we have talked about the few characteristics of 5G, now let's take a look in a simplified context of how 5G bandwidth affects the packet transmission rate using the formula of bandwidth delay. But why use bandwidth delay? This is because bandwidth delay can be imagined as a train entering a tunnel, and the train represents the packets in bits, while the tunnel represents the channel for the packets to be transmitted across a link. It can be seen that if the tunnel is bigger, the better it is, since more packets can be transmitted across the link, and this is how bandwidth delay can show that the bandwidth of 5G providing a higher transmission rate can affect the transmission rate of packets. Also, it is important to mention that we are assuming the example we are using only has one channel. So the formula of bandwidth delay equals to R times D prop, where R is the transmission rate, D prop is equivalent to DOS, where D is the distance from one source host to the destination host, and S is the propagation speed. With 5G promising a higher rate, bits can be transmitted faster. Let's make two examples, A1 and A2. A1 uses 4G with a transmission rate of 10 times 10 power of 4, while D is equals to 12 times 10 to the power of 3, and S has a constant of 3 times 10 to the power of 8. A2 uses 5G with a much higher transmission rate of 10 times 10 power of 20, and D and S remains the same with A1. Ultimately, A1 outputs a capability to feed 4 bits into the bandwidth, while A2 is able to feed 4 times 10 to the power of 16 bits, which is obviously more than what A1 can transmit. This shows how the speed of 5G can increase the packet transmission without doubt, and this will surely be handy for the employees and employers of the smart ports.
With that being said, the use of 5G will lead to lower levels of congestion. To understand this better, let us take a look at the formula of traffic intensity, LA over R, where L is the packet length, A is the packet arrival rate, and R is the transmission rate. When R is higher, traffic intensity will be lower. This is because both R and traffic intensity are inversely proportional. Since 5G network permits greater bandwidths because of the millimeter wave, it is able to occupy a large number of packets and the transmission rate will be faster. This will then result to lower levels of queuing delay, which also means that there will be lower levels of congestion. For example, let's assume that the queue size is infinite, so there is no packet loss. If traffic intensity is 0, it means that there are no congested packets, which will lead to the queue size decreasing, and so queuing delay approaches 0. Whereas if traffic intensity is more than 1, there will be more packets coming in faster than the transmission rate. This will then affect the queue size to increase without bound, and so queuing delay approaches infinity. The reason why queuing delay is affected easily is because it increases exponentially, where small increment in traffic intensity provides larger increment in queuing delay. So from that, the usage of 5G in Smart Harbour guarantees faster data transfer with the help of huge bandwidth. However, because of this huge bandwidth in 5G due to its high frequency, the signal strength for 5G is significantly lower, so more power is required to transmit the signals, otherwise the signals will attenuate and won't travel far. Hence, small cells can be used to act as repeaters and keep transmitting the signals to the closest nearest cells while bringing the data in bits closer to the destination. Putting that aside, 5G is still inevitably fast. Real-time operation can be achieved, which also in relation will increase efficiency and workflow in comparison to traditional Harbour. Qingdao's Harbour is a clear example of how 5G is implemented in harbours, which is the first ever harbour to implement 5G and also the fastest port to ever transport goods.
Alright, now for the next solution as to how 5G is the solution to Smart Harbour. First of all, the current problem with harbours or any other operator is the cost of network infrastructures. For example, when an operator wants to have a dedicated network line for customer service, another line for stock management, and another line to reporting to the HQ, there will be 3 physical infrastructures required to build a network, and it is not cheap. This will cost a lot for any operator, becoming an obstacle for further improvements, and in this context, an obstacle for smart harbours to deliver goods in large amounts. However, with the help of 5G, this cost can be greatly reduced. This is because one of the key characteristics of 5G is network slicing. It is defined as a physical infrastructure is capable of providing multiple logical networks. This is achievable with the help of 2 new technologies, software-defined network (SDN) and network function virtualization (NFV). In a simplified explanation, NFV enables network slicing in 5G, whereas SDN is the network manager that controls the data flow so that the packets know which network slice it should go to. This is because NFV decouples functions like firewall or encryption from dedicated hardware, moving them to virtual servers, having virtual machines to perform the network functions, while SDN is a control panel that allows operators to control the network management through the API that is part of the SDN. It is through this method that 5G can save costs for harbours while increasing the resource utilization for each dedicated line, bringing the advantages of a circuit switch network while greatly solving its cons. Hence, 5G can save smart harbours a great cost due to network slicing, and this allows the smart harbours to have a high expenditure to further develop the port itself for a higher rate of transportation goods, so that the port is not only smart in terms of efficiency, but also capable of staying efficient and transporting goods in a larger amount.
Another issue that is faced by these traditional ports is that key logistic operations are plagued with inconsistency and mishaps. Currently, the traditional ports have human-driven trucks that carries out logistic operations such as towing the cargo trailer and transporting out from the port. Due to the nature of that, productivity may vary, and in the worst case, accident may happen. One of the key benefits that 5G brings to the table is device-to-device communication, or in short, D2D. It is a radio technology that allows devices such as your mobile devices and IoT devices to communicate with one another with little to none involvement of network infrastructures to facilitate so. Essentially, D2D communication uses the peer-to-peer architecture to do so. So, what benefit does it provide? First off, data can be transmitted between nodes or terminals via a direct link that does not need to go through the core network. In other words, there is no need for a server to act as the centralized data center, which may lead to a single point of failure. Besides that, the end-to-end latency of 5G is significantly lower, which further improves the quality of service. Another benefit that P2P architecture has is the self-scalability it provides. As the number of nodes in the P2P network increases, the demand for data increases as well. However, unlike client-server architecture that faces the problem of the servers not being able to accommodate the increasing demand of requests from the clients, P2P faces no such issue, since the peers with the required data can share or transmit that data to other peers needing it. So, how does this actually help in building a smart pod? Well, let's take an example of a key operation that actually occurs in a pod, like the one I mentioned just now. As of now, smart pods like the Qingdao pod has autonomous trucks carrying out logistic operations within the pod with the help of an operation center to manage and oversee it as shown in the clip. This is to ensure autonomous, efficient, and uniform operation while also reducing the manpower that is needed to operate these trucks. Now, this is where the D2D communication comes into the picture. These unmanned vehicles can communicate with one another via direct link to inform nearby vehicles of obstacles that may disrupt their predefined route when transporting cargo within the compound. With this information at 0 to little delay, these autonomous trucks can avoid accidents and operate continuously with efficiency. So, that is the end of the video. If you want to do more research or know more about this topic, feel free to go to the description down below and check out yourself. And don't forget to leave a comment down below for more questions.